going to look at another basic transformation in exercise 10 here. We're going to graph the function f of x equals sine of x plus 1. So here, of course, we're transforming the sine function. So we're going to start with y equals sine x. And because we're adding 1 outside the function expression, we're going to shift upward by 1 unit. We're going to shift the sine function up 1. So I'm going to start with again, I want to put the basic sine wave on here. So this is not our final result, but I'm going to start with sine. That's 0 at 0, 1 at pi over 2, 0 at pi, negative 1 at 3 pi over 2, and 0 at 2 pi, and continues. In the negative direction, I'm just going to draw a little bit here to negative pi over 2. So there's the red graph is y equals sine x. But here we want to shift upward. We have to go up 1 unit with each point. So that high point on the graph is going to go all the way up to 2. The origin point will rise up to 0. At negative pi over 2, we're going to rise up to a point that's right on the axis. Let's see, at pi, we're going to rise up to 0. At 3 pi over 2, up to 0. At pi, we rose up to 1. At 2 pi, we also rise up 1 unit. And so our graph now is going to be in this position. Okay. And there it is. There's our graph of sine x plus 1. We shifted the sine graph up 1 unit. I just want to make a couple of points about vocabulary. On this graph, the line through y equals 1, the horizontal line through y equals 1 on this graph, we're going to call the midline. The horizontal line y equals 1 is called the midline. So as these get more complicated, we're going to sometimes have to make more of an effort to identify the midline. The midline can be thought of as what happens to the x-axis when we do a vertical shift, right? Any point on the x-axis shifts up to this midline position. And also on this graph, we say our new graph has a maximum value is 2. That's a y value. That's the greatest y value attained by points on our graph. The minimum value is 0, also a y value. That's the smallest y value hit by points on the blue graph, now our final graph. And the blue graph also has amplitude 1. The final graph has amplitude equal to 1. So the amplitude did not change when we did that vertical shift. The amplitude is not the distance from the x-axis to the top of the graph, but it's the distance from the midline to the top of the graph. And that should make sense because the amplitude shouldn't change when we lift that graph up, I guess. I don't know. So amplitude is always half the total height of the wave. And it gets a little bit confusing when we shift vertically like this to still recognize that amplitude. Okay, so I'm gonna, I can't get all my stuff on there. Come out a little bit. And there we go. Not a hard example, but important information on that one.